The last question I'll do on this page is number 5, which should give us one more opportunity to understand a word problem where a series is embedded in the context of the question, and we have to extract that information to figure out what kind of series it is and how to set up the formula for it. In this question, I'll start by reading the problem, and I'll keep in mind the idea that it's got to be one of these 3 types: finite arithmetic, finite geometric, or infinite geometric. So as I read, I'm going to think about those words that I'm reading and ask myself, do any of them give me a context clue about what kind of sequence I must be dealing with, and therefore what kind of series formula I want to use? So it says the length of the first loop of a spring is 20 inches. The length of the second loop is 9/10 the length of the first loop. The length of the third loop is 9/10 the length of the second loop, and so on. If the spring could have infinitely many loops, how long would it be? Now, I'm of course going to fixate on this word infinitely because that tips me off. It has to be an infinite series, and I only have one type of infinite series. It's got to be infinite geometric. So instinctively, I'm thinking to myself, this must be an infinite geometric problem. So then the question is, okay, if it's infinite geometric, then it's got to be geometric. It's got to have a multiplier. Which of these facts could have helped me understand a multiplier? If I set up a table of values, which sometimes helps me organize my information, let's see if maybe the multiplier situation becomes more obvious. I'll set up my n and t of n table, which is pretty customary for sequences. And I'll read the question one more time, translating the information into this table. The length of the first loop, so let's assume that's the first term, n is 1, is 20 inches. The length of the second loop, n is 2, is 9/10 the length of the first loop. Now, to interpret that, 9/10 the length of the first loop would be 9/10 of 20. And 9/10 of 20 means 9/10 times 20. So 9/10 times 20 would be, and I'll grab a calculator for this just to make absolutely sure. I'm pretty sure it's 18, but always nice to be safe. 9/10 times 20, yep, 18. So then the third loop is 9/10 the length of the second loop. So that would be 9/10 times 18, which is a little bit harder to simplify just in my head. So 9/10 times 18 would be 16.2, and so on and so forth. It says that it's an infinite geometric, but what would be the multiplier then? If I think about this for a second, I might realize I've been multiplying. To get each of the lengths of these loops, I was multiplying by 9/10. And then to get the length of the next loop, I was multiplying by 9/10. So it certainly stands to reason that of course it's geometric. My multiplier is 9/10. So now that I think about this logically, it seems as though I can confirm that this is an infinite geometric sequence. If it's an infinite geometric sequence, then I'll need to have my infinite geometric series formula to be able to find the sum of the length of the loops. The infinite geometric series formula was a sub 1 over 1 minus r. That means I need a number for a sub 1, and I need a number for r. Now thinking about this logically, a sub 1 would be the first loop in the series. The first loop in the series was 20 inches, so I'm going to interpret that to be my first term. The r would be the multiplier, which I've already established is 9/10. So theoretically, if I simply evaluate my formula, I should be able to get that total. You can use a calculator if you want to. I'll do it without a calculator just for reference. That's 20 over 1 minus 9/10. Whoops, I ended up recopying that, so ignore that step. 20 over, I meant to do 1 minus 9/10, which is 1/10. This is where we can do a keep, change, flip type of thing. So 20 times 10 over 1, and 20 times 10 over 1 should give me a length of 200. Now, in the context of the question, I just want to make sure I understand what 200 means. It's in the question asking me how long will the spring be? Well, length in this problem is measured in inches, so 200 inches must represent the total length of the spring after every single loop, around and around and around and around and around as far as it needs to go. 200 inches implies that if I took that spring and stretched it out so that it looked like it was completely flat, it must be 200 inches long. Now again, that's the important part of the question, is being able to understand which formula to use and then successfully using the formula. The sigma notation is not the most important part, but it might be worth practicing familiarizing ourselves with our sigma notation just so we can have that under our belts as well. Sigma requires two things. It requires the sigma itself with its start and stop values, and it requires an explicit expression similar to the explicit equations we've been writing all chapter long. Let's think about sigma at least at the beginning, because we want to make sure that we understand in this question the first loop that we started thinking about would be n equals 1. That's where we started our thinking. But then there was no real stopping value. It didn't tell me to stop at any specific loop number. It told me that the spring was going to be infinitely long. So at the top of sigma, I'm going to put a little infinity symbol to indicate that this was an infinite series. Now, I need my explicit expression. My explicit expression, because it's geometric, it needs to have some sort of initial value, it needs to have a multiplier, and it needs to have our power of n. So now I just need to think, how would I make this happen? I do know my multiplier. My multiplier was the same r that I was using in the formula, so my multiplier inside these parentheses must be 9/10. That part's pretty straightforward. I know that for sure. 9/10 was already established as the number I'm multiplying by each time. But then I need an initial value. And remember, when we're writing these expressions, the initial value is always the 0 term, which is not a term that I knew. When I was setting up my table, the first value they gave me was the first term. That implies that I have to go backwards to figure out what the initial value is, because I don't know that value. So let's think for a moment. If I had to go backwards, I would have to think about the opposite of multiplying 9/10. If to go forwards in the sequence, I'm multiplying 9/10, multiplying 9/10, multiplying 9/10, then theoretically to go backwards, I'd have to take 20, which is the first term, divided by 9/10, and that should give me the initial. Now the problem with this is I'm dividing by a fraction. But we've been dividing by a fraction a lot in this chapter, so I know how to deal with this. Let's do keep, change, flip. 20 times the reciprocal 10/9. That, if I multiply, would be 20 times 10, which is 200, over 1 times 9, which is 9, not reducible. So 200/9 must be my initial value, and 200/9 must be in that spot in the explicit expression. Again, I wouldn't say that that's the important part of this problem. The more important part was the answer of 200, but at least now you know that's how to write a sigma if you're asked. It's rare that you're going to be asked to write a sigma on a test or a quiz. This is more just for practice and familiarity, so don't worry too much about the sigma part. If you understood where the exact value came from, I would say you're in fine shape, and you shouldn't need to worry too much about the sigma parts if that helps relieve you a little bit. As you're finishing the page, try again to keep thinking about the idea that everything on this page boils down to one of three types of problems: finite arithmetic, finite geometric, or infinite geometric, and try to keep that mindset, especially for questions that I didn't do on a video, so that you can remind yourself you only have a few possibilities. It's only going to be one of these three types, so that should give you some guidance. And if you're not sure which type to pick, you're welcome to send an email or pop into office hours, and I'll be glad to walk you through that picking process so you know what to look for when you're starting a question on your own.